Okay, hello everyone. I know it's beer o'clock, everyone wants to go and have a cold one outside, but I think talking about Azure and talking about IoT is more interesting at this stage than having a cold beer at this moment. So bear with me. I am the last session in this on this track, but it's going to be interesting. I'm going to be taking over a few of Brady's demos in my own demo, so it's going to be impromptu demoing. And if you know me, some of my demos not always work, so please hope it works this time. I have a Raspberry Pi set up here. Speaking of IoT, this thing gave me hours of problems. I didn't really sleep last night. I had 1 hour's sleep because I was trying to figure out why the thing doesn't want to connect to the IoT Hub, but eventually got it working, so I've got a working demo for you guys. Who am I? Most of you in this room, I think, judging from the amount of people that are in the session, know me. I am Fanie Reynders, a software engineer and a Microsoft MVP. Now, what does that mean? It means I like to contribute to community contributions, community like events like this. Also involved in doing blogging and podcasting on our SDN casts, our shirts, SDN casts. Every week there's a Dutch. I'm actually not natively English, also not natively Dutch. I'm Afrikaans, so that's why I'm sort of like to do the Dutch thing every week, which is quite cool. I also work for Deloitte Digital as a senior consultant. Then there we have a lot of projects that's actually more IoT orientated as well, which is quite interesting, which I'll also talk to you in a minute. So going on to the whole notion of Internet of Things, those in the room know what Internet of Things are, right? Or what Richard said, the Internet of, what did he say? Internet of stuff. Of crap, exactly, crap, right? Because it didn't work. It's a beautiful thing because, you know, at Deloitte we have a building called The Edge, and it was my first time when I saw it. This was designed in 2015, or it was launched in 2015. It's the world's most eco-friendly building. It is beautiful because it has sensors all over, and it's an IoT. How would I say? It's an IoT heaven for people that want to make projects within the IoT space. The Edge is the place to be. They have tons of stuff. Here's some stats. They've been granted 98.4% sustainability score by Breenheim. 300,000 sensors, that's a lot. And it measures humidity, parking, temperature, basically anything you can think about, and lights, and who's in the rooms, who's not in the rooms. And it's about 70% less energy consumption, what's the word, than the rest of the office buildings in its class, which is quite impressive, you know. So moving on to the whole IoT thing, this is like not just a picture of a Raspberry Pi and a breadboard, but I actually came across this. It's a Raspberry Pi simulator. The Microsoft is busy building. So this is not done yet, but it's a web-based simulator you can go on. You can, if you don't own a Raspberry Pi, for instance, you can quickly build your IoT things, write some code, and execute it, and then it will do stuff like, for instance, there's a humidity sensor and a light sensor, and it will work without you having actually a Raspberry Pi itself. Now, the idea is you can then take this code, deploy it to a real device, and it should work the same way. This is quite interesting. Like I said, it's still limited. They haven't made it as flexible as I want it to be yet, but it's getting there. It's quite cool. So I did mention, or I don't know if I mentioned this, but in this talk is about three things, three big things. It's about IT, and also it's about serverless computing. Who has ever heard of serverless computing? Okay. Now, so serverless computing is not like what the name suggests. If you go to, for instance, a room, there's no servers and it just works. Serverless computing is basically can put it in layman's terms, it's a way of you don't have to worry about your host, where your things are hosted. Think about, you just have a piece of code and you want to execute this piece of code. It's ridiculously scalable. And there's a quote actually I have here. Adrian Cockcroft on Twitter mentioned, if your platform as a service can efficiently start instances within 20 milliseconds, and it can run for half a second and shut it down, you can call that serverless. Which I think this sums it up. If you want to be talking about serverless technologies, completely fast, get the job done, switch it off, get resource free, and move on. I'm going past these slides as a madman because I want to actually get to the demo to show you guys how beautiful that thing works. So the last thing is continuous integration. People here put their source code somewhere, right? So in the repository. So continuous integration, just for completeness, is a way of, when you build your, it's a way of when you check in your source code, it automatically builds it and validates it against unit tests. Does the thing work? And if it doesn't work, it will flag it. If it does work, it will flag it as a trigger, so they can actually hook onto processes that way. So that's a concept of continuous integration, and it also goes onto the continuous deployment to automatically deploy this on devices like the Raspberry Pi. Here's like a sort of a diagram I found. So the developer checks in his changes, the source control server saves it, and then it triggers up a build, depending on how you set it up. This can be on a time basis, like every night or something, or it can be on each check-in. The build server, in this case, in my demo, it's Visual Studio Team Services. It builds the source code, runs the unit tests, and depending on if it fails or succeeds, the integration server sends out an email or a message to the rest of the team saying something is up or something was not up. In my team, this was a problem because, I hate emails. And like Brady mentioned, all those emails he's getting, just imagine if you're getting all those build failure emails. I normally go Control A, delete. I don't even read them, so it's actually a waste of my email space. And notifications like these doesn't belong in an email system. You can make it clever, build something like I'm going to show you now, like a lamp that shows you at the first glance did it work or not, and you can also extend it and make it clever. If it does not work for the 5th or 6th time, then send out the email. Right? Be a bit more conservative on your emails. So this is how it's going to work. The developer, Brady, just give it a name, he's going to be checking in his Hello World app. And depending on what the code does, Visual Studio Team Services is actually this. He's going to build it, and depending on what's happening, the build's going to pass or it's going to fail. That's going to send a signal over to my Azure function, which is my serverless technology, my little code running in Azure. It will strip out all the unnecessary stuff, get whether it's successful or failed, and then send that through something called an IOT Hub. Anyone know what an IOT Hub is? No one. Well, Brady knows, obviously.
I don't know how to differentiate it from the other products, like what it does that the other does.
So IOT Hub is more specifically for IoT stuff. As I understand it, it's built on top of Event Hubs, which is built on top of Service Bus kind of thing. So it's completely compatible with Event Hub if you use it right. So the IoT Hub is very important by connecting the cloud with the device. So it's a hub of traffic going through there, and you can totally see the traffic going backwards and forwards by using the tooling they provide. So the IoT Hub is absolutely paramount in having. So the message just goes through our whole IoT Hub from the Azure service, from the Azure function. It reaches then the Raspberry Pi, and until, why should I do all this? Light up a little red or green light on my breadboard there. The problem I had with my Raspberry Pi, everything was working perfectly up until here. The problem I had was it cannot connect to the IoT Hub for some reason. It saw it, but it could not get messages from it. Eventually solved the problem by flashing the SD card, reloading Windows 10 IoT Core, and then eventually it just worked. You know, it's like, let's deploy. Don't change it. So what would you need for this demo? Obviously you would need a Visual Studio Team Services account. Feel free to take a picture of this if you really want to go play with it offline. I've created a repo on GitHub containing all the material that will give you the possibility of recreating what I've done here, except for the Pi, on your own account. Just get a Pi, plug it in, and it will work as I'm doing here. I've made it easy for you guys. You need an Azure subscription. You can get one at azure.com/free. You need obviously a Raspberry Pi with Windows 10 IoT Core. Get that at the site. You would obviously need a tricolor RGB, which is the red, green, and blue LED, and a which is helpful IoT Core dashboard application, which I'll get to in a second. So I think this is the slide. I'm switching over to code, so if you don't mind me sitting. Duplicates off. Okay, great. So this is the thing I was talking about on my GitHub, Fanie Reynders /SDN event June 2017. One thing to note that the master branch is not the branch you want to be in. The master branch is just a branch to show you where all the stuff is at. Because we're working only on one repo, I had to sort of use branch. I had to sort of use the branch strategy to sort of get all these things working. So we can just go to the branches. You can check out the assets, device, or webhook branches containing the relevant code that you would need to sort of get this thing going. So where would we start? We would start by actually pulling this repo down, and I would use this by doing it in code. So obviously I'm going to open code now from this directory, and then let me see what's happening here. So in the terminal, I'm going to say git clone. I don't know what the URL is, but you basically go and copy paste that. So it's like that's doing a duplicate, but in any case, so it's cloning it into the SDN event folder. So SDN event. Is this fine? Is the font fine there? Can you guys read? If I need to slow down, just please tell me. So the first thing I need to do, I want to switch a branch to the actually you see here. There are many branches. There's the assets branch. The assets branch till date only includes the assets for Azure and for VSTS. But now with the CLI, you would see now it's like hot off the press from Brady. I'm just incorporating it into my demo. Is the CLI parts, which is much less code than the actual JSON that Azure gives you. Just to show you an example, this is the template from the Azure Resource Manager. This is the whole thing you just have to copy paste, and you have to understand, and it's a bit hectic, right? So I choose to sort of not use this now. Instead, I'm going to be using the Azure CLI to create my environment in Azure. So let's do that quickly. In Azure, instead of going to click file on the UI, I'm going to be creating it. I'm going to come back to Azure. I'm going to show you how to do it from the UI, or you can just use this script and you're good to go. So the script that's not yet in source control, which will be in source control, is this guy. What we're going to do is we're going to be, if you be logged in, AZ login, you're going to be creating something called a resource group. So that's a group to sort of house all your resources in Azure. We're going to call it SDN Awesome Demos group. And then I'm going to be creating an IoT Hub that's paramount for our demo. And that IoT Hub will be named SDN Awesome IoT Hub. Then I'm going to be creating an app service plan. not going into detail what that means, but the app service plan is a way to sort of measure. Brady, please help me. What's this?
Like a server farm.
Yeah, it's a good enough. Yeah, it's like a service farm. Then you need a storage account for I don't know what reason. You just need it. Honestly, I think it's the way the function app hosts its stuff. Then lastly, we'll create a function app called SDN awesome function. The last one I won't execute because that obviously deletes the whole container. I should have actually executed this while I was talking because now it's going to be an awkward waiting again. So like Brady showed you earlier, this is quite cool. I'm going to try this for the second time. It's actually awesome. Run this. This is an extension, by the way, for those that weren't in the previous talk. In Visual Studio Code, if you go to the extensions part, you can download the Azure CLI tools here. And then when creating a file, you must create your file. Does this work? Test.az CLI. So Visual Studio Code picks it up as a CLI thing. And how do I exit this zooming thing? No idea, like that. So while that thing is running, I'm just going to pull it down. You can do stuff like, it has intelligence. You can say AZ, and then it will pick up my accounts details. So you can go AZ account clear or AZ group create, give it a name. So it has cool intelligence to help you sort of create these things. So if this is in GitHub, you can just pull it down and execute it like I've been doing now instead of going to Azure and rocking it from there.
Minus the delete.
Minus the delete, yes. Otherwise you would. Is there a way of commenting it out?
You just use traditional.
This is like hash? Yeah, cool. I'll save this. So this is basically all you would need. So let's just see how far this guy is. Now, while this is going, let me quickly show you the UI. Any Azure customers in the house? No one is using Azure? One? Two? Do you guys know what Azure is? It's the cloud. Okay. So it's the cloud. So this is the UI. I've sort of made it bare bones to have everyone understand what I'm trying to do. First of all, we have our resource groups on the left. Now it's busy provisioning the SDN awesome demos. Second of all, I have my IOT hubs. You see all your IOT hubs. To create one, you just go click add. The reason why I didn't go this route because it feels slower than just executing CLI, you know, and time is of the essence if I'm going to be doing hopefully some code. Functions, same thing. Functions is built on top of Azure Web Apps, which is built on top of VMs, isn't it?
Yeah.
Yes.
It's built on top. Everything's built on top.
Yes. So yeah. So the whole idea of Azure Functions, it's sort of an idiot-proof way of creating serverless functions to actually execute. So momentarily, there will be a function popping up here somewhere. And while that's happening, and yeah, that's basically all you would need for your infrastructure in the cloud to work, right? While that's busy doing its thing, I need to go to the right tab. If we go to the webhook one, because obviously a function is just a host with no actual functions within, it's just the infrastructure. Because I've did the wrong. Because if you switch branches, if you're too deep and it doesn't have that same files, it breaks. Switch there. So the whole concept of Azure Functions, it's just the infrastructure that's put in place in Azure. It's that code that executed won't create the code that does these LAMP thing. You still have to implement it somehow. This branch, the webhook branch, will do that for you. So if we quickly look at a code for this, it's actually quite cool. But let me first show you how easy it is to create an Azure function within Visual Studio. Brady showed it in his previous example in Visual Studio Code. I'm just going to go click Visual Studio Enterprise. This is the preview version. 2015, the proper version was out, but now it wasn't supported in 2017 yet, but now with the preview version of 2017, it's now supported and it's baked in, which is quite cool. To create one, you can go File, New, if my mouse works together, or Control-Shift-N, that will also work. Go to Web. You know what? Actually, I'm wrong. Give me a sec. I need to switch a branch here. Oh yeah, here we go.
I think you'd have to pull it down with that branch. With the dash B command.
My branch thingy is not here. So we can go Git, check out webhooks. I think initially. What's happening now? Initialize repository. I don't know what's happening there. So now I picked up all my stuff. Okay, now I can actually go and switch the branch. For some reason I don't know where with the other wings ones. Okay, now pulling up the Webhook one. And Git check out Webhook init. So this is what you want to be doing. So you want to be having a empty solution, which is in Visual Studio. I was just now lazy to create it, but you can go git check out Webhook init and follow it from there. This will open up an empty solution, and then once it's loaded, you can go create a new project. Go to cloud. Was it here? This is not preview. It's wrong. This is a wrong Visual Studio. That's why. Bear with me, guys. Sorry. Having so many things happening here. Need to go demos. June. You want to be opening up that solution, or a solution, any solution really. Create new project. So look, there's preview standing there. That's how we'd know. Go to cloud, and then you go create an Azure function. Give it a cool name, like Martin van Stam or something. And then after a while, it will create this. So this is what Azure will do. It will just create this for you in the cloud. Nothing more. You still need to implement your functions. To create a function app or actual function, you go click Add New Item, and there's a new item, Azure function. Call it something. Click Add. So this is just the UI way of doing it. So there are plenty of functions. One of which is a Event Hub trigger. So if something lands in Event Hub, it's a trigger for you to do something. There's service bus queues, timer triggers, face locators. You can go wild. You can save the world with these functions. The one we're going to be looking at is a webhook, because from VSTS it supports webhooks. When there's something happens, you want to be hooking into your Azure function. So we first need to create our Azure function to be hookable, and then from there we'll build it out further. So we'll create a generic webhook. And after a while, it will go in. You can probably do it much faster in Visual Studio Code now, I believe. So this is a.
Actually, you can.
Yeah, exactly.
The only thing that's faster than doing this in DS is they actually have a pretty early command line tool. It only runs on this. So
Okay. Interesting. So this is a function. So what Azure will do is, if on a certain endpoint, so each function has an endpoint. on a certain endpoint, it will execute this run function in this class. You can have parameters like, you know, do you want JSON, do you want your log and stuff like that. But this will just execute your webhook. It will get the content, it will execute it, and it will send you a greeting back. I'm not going to run it because of time constraints. This is as easy as it can get in Visual Studio to create a function. So, but luckily for source control, I have created one for us. If I just maybe reset my whole, undo, discard all changes, and we go final. It will reload the solution. So what will, what? No, something is not right. Let me just open this in GitHub or Visual Studio. I have a folder, awesome webhooks, and in here I have the VSTS webhooks that I've created. Quickly talk to you through this code, exit there. What it does in very, very short term, it gets the, something's happening. It gets the JSON, it parses this JSON object or this request into a data object, and from there it tries to read the status object, the status property from the resource object, and then that's the thing I was talking about. It extracts the status of the build. This is specific to VSTS. So if you would be using GitHub, they have a different structure. So you would be able to just replace this one line because this is a VSTS webhook, right? So or you can make a generic one as well if you want. It's reading the connection string out of the configuration of the IoT Hub, because like a SQL connection, the IoT Hub has a connection to connect to. Then it's going to be creating a client to connect to that IoT Hub. I'm going to be sending a message to the awesome device, which is this awesome device over here. In Azure terms, this device is, where is it? This device is the logical device. So you set up devices in your IoT Hub, and you map them or provision them to the physical devices with the dashboard tool. And then it will send this message as a new message. It will get the bytes of this build result, in other words, this object, and it will just work, right? So to get this into Azure, because it's in source control, you can quickly, if this is done, did it work? SDN awesome. There we go. So it didn't bring in any functions because there isn't any. So what we do is we click on the function, go to platform features, and then we configure continuous integration. Because that's in GitHub, I'm going to set it up to use GitHub. I've already linked it up, so it won't prompt me for username and passwords. So I choose a source is GitHub, and eventually it will go further. Authorization I've done already, my organization I've done already, my project. Now it's important for this demo to choose the right project, which is the SDN event repo. And this is why I chose the branch strategy, because you can only pull from a certain branch. So you now choose the webhook branch. That's the meat of your function actually. And that's it. And then there we go. Now it will actually go and pull the source code, deploys it into Azure. And whenever I change the source code of my webhook, check it in, it will deploy it to my webhook. You know? I was actually thinking of building this whole thing in, make the build temp fail if my webhook is not right. But then I ended up with the endless sort of a loop back chicken or egg thing. So I was like, no, rather not. Let's just make a different demo for this scenario. While that's loading, let me show the actual Hello World application that Brady is going to be working on, that he will actually build. So Visual Studio Team Services, I've made an account for myself, Fanie Reynders of visualstudio.com. There is an awesome project over here, and I've set up a build definition. So there's the code. You can quickly, it's a .NET Core application, very, very, very basic. All it says, hello world, right? You have a build and release tab, which is all your build definitions. I've already set up one. If you really want to go as far as you don't want to set up your build definitions, you can just also pull that off source control. Just read the documentation I've put on the repo. You can also get it in here by clicking on this and say import. You can import your build definition from an external source. How does this build definition look? I see I got a 26% success rate, which is great. It's the best. So what this build does, this has nothing to do with the demo. This has nothing to do with Azure at all. It's demo purposes. So this is my demo application. It's going to get the sources. It's going to do a .NET restore. It's going to do a .NET build, and that's it, right? At the triggers, I want to be doing a trigger every time there is a check-in that I set here somewhere. I think it's this one here, and that's it, right? The next step, I'll get back to this now. Let's just see how it is here. At still deploying. Sometimes this is very slow, so I need to sort of Control F5 this guy to make it show up. I haven't written one single line of code yet. I've all pulled from source control, which is great. There we go. There's my VSTS Webhook. I've just created from GitHub. Here we go. There's the binding information. Also note, the moment when you hook it up to source control, you cannot edit it online. If you don't have source control, you can still change it online. But the whole idea of having a source control is have one place of truth. So you can imagine if you want to be changing it online, and there's, you know. The cool thing about this is now I can test this. I can run this now, and I can see how it works. What I will do before I run this, I need to sort of add the connection string, because we have this awesome IOT Hub connection string it reads out, and it does not have that connection string yet, right? So first we need to go and get it. So we go to our IOT Hub that was created earlier by that wonderful script, and we need to do two things. We need to go and create a device, a logical device, because that logical device does not exist yet. Like I said, Azure is just putting in the infrastructure for you. You still need to implement it. Create a new device. The device ID is awesome device. Everything's awesome. It's great. Okay, there's our device. And if we go to the shared access policies, that's sort of roles of determining who and what role can talk to this IoT Hub. So we want to be choosing the service, because the function is going to be talking to this IoT Hub. And the service role is the best, actually, to use. So you pick the service, or the service, and then you can just copy the connection string, head over back to your Azure function. Someone's having a party outside, I see. Then platform features, application settings. Now this is environment specific. So you won't be checking this into source control, please don't. Because if someone pulls the stuff, you know, it will be crazy. So what you need to do is, on the platform features, select application settings, which is this guy. And it looks very similar to the app settings, right? So here you put in your awesome IOT Hub, and you paste it in there. Save. Now we have everything. Now we have everything we need for the IoT Hub to talk to the for the function to talk to the IoT Hub, and we can actually test it now, see if it works. And I wonder, should we just go through and see if this whole thing works and debug it later on? I think we should do that, because running low on time. So now, going back to the function, we need to get the function's URL to tell Visual Studio Team Services what to execute. when it finds a build definition. Here on the right, I wonder why it's so hidden away actually. It gets function URL, it's not really obvious. So you can just copy this guy. And you go back to the build definitions. There's a settings tab.
There's some changes coming to the segment of the portal. So.
Okay. That's good to know there's changes coming. And we need to go to service hooks. Create a new subscription. And then choose your poison. So in this case, I'm going to be going for a type of subscription webhooks. Next, I want to be triggering every time a build completes on all definitions, on all statuses, for instance. The URL, which is quite handy. So you just jam the URL in there. And you can also put authentication in there if you want to. And you can test it if you want. So let's just see. Test. Succeeded. So that means it got a 200 from our function. Whether it sent out a message to the IoT Hub is not relevant, because this payload does not really have anything to do with the problem. I think actually what's going to happen is my light will go on when I start, because it's a queue kind of thing. But our function is hooked up now, so we have communication now from Visual Studio Team Services to the function, and function to the IoT Hub. And if it's good, the next step would be to hook up the device to the IoT Hub. Okay. So for that, we can actually test. I need to. Where's my phone? I need to connect with my. I need to connect with my hotspot. What?
You have to click the finish button, or is it already?
Didn't I click finish? There we go. Great, thanks. I'm just going to quickly connect to my hotspot here. I'm not able to connect with my hotspot. Why? What? No. That's weird. Buggy. Mobile data was off. Okay, great. So connecting to my hotspot, and then obviously here I need to also connect to my hotspot. So just give it a sec. Secured. There we go. So now, how does the device know where my connection string is? Now, look, I can give it hard-coded values to my device and say, here's the connection string of the device. So if you move your attention over to the IoT Hub, we open this up.
You use the hotspot because you have to be on the same
yes.
network?
Yeah, I use the hotspot because I need to be on the same network, but that's for later. I will explain now why. So if you go to the Device Explorer, I've created my logical device, right? But there's no link to the physical device yet. I can click on the one way of doing it, the hacky way of doing it, is clicking on the device and copying this connection string, stick it into the code, and it will work. But that's not secure. Anyone can steal the device, grab your connection string, and do stuff. So how would one go about doing that? So it turns out that there's something called TPM, which is the trusted, what's it called? Yeah, that. And for some reason that sort of escaped me, but it's a module that keeps passwords safe on hardware level encryption. So to set it up, and obviously now I haven't, and this is proof, I haven't pre-programmed my Pi to use that, because I just created it in front of your eyes, so the key is different. So right, and I'm not going to deploy it now. We need to provision our device first on Azure. So using the IoT Hub, IoT dashboard I downloaded earlier, you can go to connect to Azure. It will pick up your devices here if you go to my devices, if you're on the same network. But you want to connect this device now to Azure. So I click connect to Azure. and it's going to pop up all my hubs and stuff that I would need. So here it sees, oh, there's my IoT hub, there's my logical device, which is quite cool, and choose a device to marry it to. In this case, it's my Pi. It's going to pick up that it already has been provisioned earlier, but I want to override those settings. So I'm going to be provisioning it. And what this has done now, it took the connection strings from Azure, embedded it into the chip of the Raspberry Pi, hardware level encryption. No one can get there. It's immutable, and only via code you can read it out. And let me show you how the code looks like. But let me first run it first, and then we'll get into the code. So now it's provisioned. Now we can actually run this guy. So if you go to the Raspberry Pi, opening the portal, to log in quickly. And if I go to my apps manager, there's my application that I've installed previously. So it's going to be using the old application that was there, that's already been deployed. The reason why I'm not doing it here is because it takes time for deployment, but it's going to be using the new configuration, which is important. What I also want to do, I want to be launching a remote client. So this is a view. If I'm going to be plugging a screen to my Pi now, this is what I will see. It's a remote view. So I'm going to keep this open. I'm going to go to my portal. I'm going to launch my app, start. And when it launches, we would see a blue light. Blue light means it's idle. Okay, so that means okay. Now the previous thing came in, so that's green. So that's awesome. Yeah, it works. So now my previous build is green. So okay, imagine this is now sitting on your wall somewhere, and let's test it out. There's also a UI I've made to sort of show for backup if it works or not. But anyways, that's the sort of UI. So let's go over to Visual Studio Team Services land and actually change the code. We actually have let's do a proper developer workflow.
Meaning force and error.
Yeah, force and error. Yes, exactly. So let's see where is this dev. Just repeat the question. Depending on what protocol you use. So at this stage I'm using HTTP, so it's a poll. But there are other protocols that uses push and stuff as well, which is more performant. Yes, exactly. Also, because I had so many problems, I know HTTP works, and I had problems with others once before. But yeah, you're totally right, you can do. So what we'll do is, we'll go back to the awesome, this is just like syntactic sugar I'm doing now. How can I clone this? Clone. Let's do a whole developer workflow, right? So let's go to a sandbox environment. Not there, and we go git clone our program, not got git. There we go.
It's just the past tense.
Yeah, I got it. Exactly. So now let's break our build. Brady logs in. He's like, okay, what's happening here? There is awesome. So let's go cd awesome. Let's go into code with this guy. I'm not even going to think about it. I'm just going to go in and break it. So this is a .NET Core application. So let's remove, if this thing works with me, so let's remove a few lines of code. Let's break it completely. This will obviously break, right? If it works, they don't take any responsibility. Let's go Control S, and then using the great Git integration from Visual Studio Code, I can say I messed up. Check that in, and push it back to the server. So immediately now, what's going to be happening? Also keep your eye on this on this light for a sec later. If I go to the build and releases, it will trigger a build. It's in progress. This is the kind of things you want on a dashboard somewhere, right? Now it's initiating the agent. So imagine this is your dashboard, everything is running, so it's waiting for a hosted agent to come up. I'm going to hold this so anyone can see. It's running the build, .NET restore, that will work, that will take a few time. Does anyone have questions so far? Am I going too fast, or is it a good pace? You know, you want to see a red light? Okay, now we'll Brady, red light, please. Yeah, there we go. Hi, Mom. she's always watching me, you know. Okay, so let's see if this works. Should be done any second now. I don't know why this is taking. This is a small application, or it's pulling down the whole .NET Core framework. And then build. Our light will go red. So that's how it works. So thanks. Do you guys want? There are like 15 minutes left. Do you guys want to see the code on the device? How it looks? Very easy. It's great. It's. So what we do is we would open up a terminal. What's the terminal? T. What? How do I put terminal in Visual Studio Code? View terminal.
It's control tilde.
My tilde doesn't work on the server. So it's yeah, it's crazy. It's not mapped properly. So let's go git checkout device final. And okay, now it's got the whole other stuff in there. Just git reset hard. It's got the other stuff in there in any case. Not a big thing. So it has two things. It's a normal UWP application, Windows Universal. And this is also obviously on my GitHub account. What we have is, this is just for the UI. I create like solid brushes. This is important. There's the 3 pins that I use. The red pin, green pin, and blue pin. And then once it starts up, it initializes the device by getting the default GPIO controller. If it doesn't have one, it will give you a big fat error message saying I don't have any pins, which is obvious because if you run it on a laptop, it will break. It doesn't have any pins, but you can work around it if you want to have generic. You can say if this, and then just carry on. If it has, then you open up certain pins. If the red pin, according to documentation, it's a bit wrong. I figured it out. 2 pins was swapped around. I will just actually send a pull request on that, you know, to fix that. Red pin is pin number 5, green pin is pin number 6, and the blue pin is pin number 13. Now that's the pins that are here on the side here. Don't worry about the colors of the wires. I tried to sort of keep to the colors, but I didn't have a green wire. So then when it starts up, it will light up the blue function, or the blue light. So here's my functions: the blue light, green light, and the red light. So when it's a blue light, I just write nothing to the red pin, nothing to the green pin, and everything to the blue pin. And same goes with the green: nothing to red, everything to green, and nothing to blue. And same for red. So what's going to happen when the thing starts receiving events? You see on top, it starts receiving events asynchronously. This is important. There are no connection strings. I create a new TPM device on location 0 because a TPM module has certain, I think there are 10 or 9 segments that you can choose from. I just choose the first one, 0. When you provision it, you also have to choose which segment you want to provision to. Then I get to URI by just going my tpm-device.getHostName. And I need my device ID, so I just go get device ID. And I want to get my SAS token, which is a dynamic token that expires every hour, which is more secure. Get it there. Jump it into a factory that creates me the whole token, pops your uncle the runtime, sorts everything out of the TPM module. This is a very secure way and industry standard way of reading connection strings out of your device, if it supports it. Then I go into an endless loop, waiting for messages. So I use my client, say, receive message async. If I don't have anything, I just continue. If I have something, well, you guessed it, I get the build status. I also need to translate my build to a color, and this is how I do it here. So when I get a failed, I light a red one. If I get a green, I light. If it gets succeeded, I light the green one, and then I complete the whole process. And that's all she wrote. It's that easy to create a build lamp for Visual Studio Team Services in just under an hour. Thank you very much, guys. If you have any questions, please feel free. I'm going to put up my contact details there on the screen. You can find me at my Twitter. I'm not as active as Brady on Twitter, but you can still hunt me down there. And also, I don't receive as many emails as Brady does, but I will reply to your emails. Thank you.